So as you can probably tell, my project is going to be about lasers. Now, we all like to have fun with lasers occasionally, shine them into people's eyes, burning their retinas, blinding them, great stuff like that. But the thing is, most people don't actually know how lasers work. So to start off, laser actually means light amplification by stimulated emission of radiation. And if you notice, I'm using a laser during my lasers description thingy. So some basic info about lasers. They're monochromatic, which means they have a single output wavelength, or they have pure color with an extremely narrow like line width, so like the light doesn't spread out everywhere like a flashlight. Lasers can have all different kinds of wavelengths, from ultraviolet to infrared. Different wavelengths are used for different things. For instance, UV lasers are generally used for cutting metals and plastics, things of that sort. Lasers are highly directional, which means you can point at something and it'll just stay right there. It doesn't spread out like a flashlight, kind of like we already talked about. And all waves of a laser are in like phase with one another, all exactly in phase. So kind of like we talked about in the waves chapter, you can have constructive interference. Well, this is kind of like always having constructive interference. So if you have, if the wave is like that, all the other waves in that laser are going to be matching up peak to peak, trough to trough, like that. Now, to understand lasers, we have to understand some things about atoms. Okay? So here we're going to be using a hydrogen atom just because it's the easiest, only has one electron. We all took chemistry, so we all know what a ground state is and how a photon causes it to be excited state. Then after a short period of time, the photon will pop back out and go back to ground state because it wants to be a ground state. Now, another thing that can happen, it happens in lasers. It just uses the basic slurp and blurp method. So you have a photon here, it comes in, this pops down to the excited state. Okay, so slurp. And then another photon comes on by. This one also comes in. Whenever the second one comes in, it takes both photons out. And this goes back to ground state. Blurp. Now these two photons that have just been popped out right here are exact copies of each other, which is going to be really important later. So this is the basic structure of a laser. You have a mirror right here of 100% reflectivity, so nothing will get past it, it'll all just stay here in the gain medium. You have a mirror of about 98% reflectivity right over here. And then you have your gain medium, which is where all the atoms are that are gonna get excited, and the gain medium is there to produce identical like photons. So in the gain medium, it's usually just going to be either a gas or a solid. Example of a gas would be CO2 or krypton, and an example of a solid would be neodymium doped yttrium aluminum garlet or neodymium doped yttrium lithium fluoride. And so the last part of a laser is going to be like a little coil that goes around this gain medium, and it's an energy source which is just there to initially excite all of that, or to put all the atoms into the excited state there. And whenever it does that, it's called optical pumping. Now let's take a closer look at the inside of the gain medium. So we use, let's say, black for atoms at the ground state and red for excited state. So initially, this is on the inside of the gain medium. Got a bunch of atoms and stuff all at their ground state. Now, the energy source is going to emit photons, which make these atoms go to a higher energy level. So they start, what is it? Emit, whatever, emit photons, not emote. Emit photons, not emit, yeah, anyway. So now all these red ones are going to be excited, atoms at the excited state. Now, how we talked about earlier, After a minute, it'll shoot a photon out. So now there's a little photon that just got shot out of this one. This goes back to its ground state. And so the next thing that will happen, this photon will probably end up interacting with one of these other excited atoms. When this goes into here, as we talked about previously, two identical photons are going to get shot out, which starts a chain reaction making a bunch of photons of the same kind. And only photons with the same amount of energy and momentum would be part of this chain reaction. All the other ones will, so if this is the gain medium right here, they'll like fly out here and stuff. So this is why they're really strongly coherent and monochromatic, because it's only identical photons in this chain reaction. Now this is very important. For a laser to work, there has to be more excited atoms in here than atoms at the ground state. So if all these were at the ground state and like this, well, the laser wouldn't work because there's way fewer excited atoms than atoms at the ground state. So now let's take a look again at this mirror right here of 98% reflectivity. So it's 98%, so it'll for the most part bounce the photons back, just like this one of 100% over here will. However, it does allow some of the energy to end up being emitted out of here. So some of these photons are going to be flying through here, going this direction, which is why you can see it, which is why whenever I point this laser, these are all of the photons that ended up escaping the mirror with only 98% reflectivity. So there are many different uses of lasers today. As we said earlier, you can use it to make people blind, but you can also use it to fix their vision, so you got a pretty good trade-off there. What I like to focus on right now is military usage. So things such as the Strategic Defense Initiative, or as it was commonly known as Star Wars. It was Ronald Reagan who was the president during that. Those kind of pictured up here, there'd be a ground laser as well as lasers up here in space, which would stop intercontinental ballistic missiles, such as the one shown here, by pretty much just shooting a bunch of photons at certain wavelengths that would make it blow up in midair. So that's kind of neat. And also this little plane down here. So the government or military has said that they expect to have lasers on fighter jets by 2020. And so if you want to kind of think of something that could possibly be similar to this, think of Iron Man. How he shoots his lasers. Might seem kind of far-fetched, but what would happen is they would have little lasers on here that would shoot photons and things at a certain wavelength, and power and all that kind of good stuff, to where it would be able to pretty much chop through planes and metal and just anything it would really need to up there in the sky, like Iron Man. So that's how it would work.